Have you ever noticed how after you finish cooking, if you drop some water on the hot stove, the water will seem to levitate there, floating around the surface of a cooker like some ethereal entity? I'm sure students will recognise the scene depicted here. This amazing physical phenomenon is actually down to a physical effect called the Leidenfrost effect. Johann Gottlob Leidenfrost, the phenomenon's namesake, was a German doctor who was the first to record the effect. In his book, A Tract About Some Common Qualities of Water, he noted that water dropped on a hot surface seemed to float there, like in the video shown earlier. What's actually happening in the case of the cooker is fairly simple to explain. However, the applications and extensions of this effect are fascinating, and whether the effect happens or not depends on whether the surface is past a certain temperature called the Leidenfrost point. When it is below this point, water dropped on the surface will simply flatten out and evaporate away. However, when the surface passes this point, the Leidenfrost effect comes into play. The bottom part of the water droplet vaporizes immediately upon contact with the hot plate, forming a gas layer of water vapor that insulates the rest of the water droplet from the heat of the plate. This is due to the low thermal conductivity of the steam. Also, the reason the water droplet moves around so freely is due to the low drag coefficient of the gas cushion below it. Although this effect doesn't look all that impressive when concerning a water droplet on a hot surface, it has some amazing extensions. For instance, it allows a person, after dipping their hand in water, to then dip their hand into a container of molten lead for a short period of time, without injury. This is due to an insulating gas layer forming around the hand from the water, and so insulating the hand from the intense heat of the lead. Dr. Heiner Linke and his colleagues at the University of Lund in America also discovered that when a water droplet exhibiting the Leidenfrost effect is put on a grooved surface, the droplet can be made to move in the direction of the grooves. The reason for this movement is actually very complicated, but it is essentially due to asymmetry of the water droplet and conservation of energy laws. This led him and his colleagues to create a maze of grooved pathways where the droplet follows the direction of the grooves. He argues that this movement could be used for cooling systems in circuits and small electronic devices. The Leidenfrost effect can also be reversed, where instead of putting the liquid on a surface, a heated surface is put in the liquid. Work done at the University of Saudi Arabia showed that when using spheres of metal coated in a superhydrophobic surface, the insulative gas layer that forms around the object can be maintained at a temperature much lower than the Leidenfrost point, reducing drag up to 85%. This has potential applications for travel in water, such as coating submarines or the hull of boats, reducing drag and reducing energy costs to propel the boats. The Leidenfrost effect is a simple yet beautiful physical phenomenon, with some extremely useful possible applications that I'm sure Johann Leidenfrost couldn't have thought of in his wildest dreams.